Today we are going to be learning about linear velocity and its many practical applications. Velocity is the ratio of the linear displacement of an object in time, or how far something moves divided by the time it takes to move that far. One of the most common measurements of linear velocity is miles per hour. Now let's calculate linear velocity. Your family is driving down the highway on your way to Grandma's house for Thanksgiving dinner. You just passed a sign saying that you are 28 miles from Grandma's town. If dinner is at 7 p.m. and it's 6:35 now, how fast will you have to drive in miles per hour in order to make it on time? Remember, how fast you have to travel will be your linear velocity. Well, let's analyze this. You have 25 minutes to travel 28 miles. We can now calculate linear velocity. So the velocity is equal to 28 miles over 25 minutes, or 1.12 miles per minute. We need miles per hour, so let's do a conversion. Multiply 1.12 miles per minute by 60 minutes over 1 hour. The minutes cancel, and we are left with 67.2 miles per hour. So you'll have to drive 67.2 miles per hour in order to make it to Grandma's house by 7. Mind-shattering, right? Yeah, I know, not really. So let's make things a little more relevant. On November 12th, history was made. The European Space Agency's Rosetta spacecraft and Philae lander reached Comet 67P, and Philae successfully landed on the surface of the comet. Traveling at a speed of 34,400 miles per hour, it took Rosetta 10 years to reach the comet. The only question that remains is, how far did Rosetta travel? We know that linear velocity is distance over time, but we already know the velocity to be 34,400 miles per hour. But we also know that it took 10 years for Rosetta to reach the comet. So, by using the formula for velocity, we can calculate the distance. Wait, we need hours, not years. Time to make some conversions. 10 years times 365 days over 1 year times 24 hours over 1 day equals 876,000 hours. If we take that value and multiply it to either side of our original equation, we can solve for distance. So the distance is 3,013,444,000 miles. This was a great example of how you can use linear velocity to find values for things other than speed. But it is actually false. It would be impossible for a spacecraft to travel 3 billion miles under its own power. Watch our video on angular velocity to find out how they did it and learn a little math on the way.